Hi physical science students, welcome to Ionic bonding. This is pretty much based around chapter 4 of your textbook. So as I'm working through this theory, just make sure that you're doing some reading in chapter 4 of your textbook. So before we get into ionic bonding, we just need to make sure that we are aware of the three different types of chemical bonds that can occur. There are the ionic bonds, which we're going to do now. There are what's called metallic bonds, and then there are what's called covalent bonds. The ionic bonds are when we have a metal atom bonding with a non-metal atom. So remember from the periodic table, that was the metal atoms are on the left hand side of the staircase and the non-metals are on the right hand side. So when you get something like sodium and chlorine, metal, non-metal, that's going to be recognized as an ionic bond. The metallic bonds are the bonds that occur between the metal atoms, so anything on the left hand side of the periodic table. Covalent bonds are those that occur between the non-metals and other non-metals, either themselves or other non-metals. And something like carbon dioxide is an example of covalent bonds. Now we're going to look at ionic bonds firstly, but then we're going to eventually work our way through and look at metallic bonds and covalent bonds as well. In ionic bonding, we will be learning how we get the formation of things called ions, which we've touched on already, the relationship between the structure and bonding of ionic materials and their properties. So we will be able to explain each of the properties based on the bonding model, because there's not much point in having a bonding model of how ionic substances bond if it doesn't actually explain all their properties. The importance and limitations of the ionic bonding model: it is a model, it's not perfect, it doesn't explain everything, but it works pretty well for us in physical science. We're also going to learn chemical language, symbols and formulas, just as a matter of course, and the physical properties of ionic substances, and models that represent the ionic structure. So what does it look like, or how do we try and visualize what it looks like? So what are ions? We've mentioned this before, but let's just do a quick recap. Ions are formed when atoms lose or gain electrons to achieve the stable electron configuration of a noble gas. Remembering the noble gases are the group 8 elements in the periodic table. Okay. Metals lose electrons in order to gain a full outer shell and become positively charged ions. Now why do they lose electrons? Remember the periodic table when we were looking at the groups, and each group in the periodic table indicates how many electrons are in the outer shell. The metals have less than half of their outer shell filled, so it's easier for them to lose electrons and then get a full outer shell by losing the electrons than it is to gain more electrons to get a full outer shell. Now by losing electrons they become positively charged because, remember, the nucleus contains protons and those protons are locked in the nucleus. It's the electrons that can come and go because they're fairly loosely bound, and so by losing electrons they become what's called cations. Ions that are called cations. Non-metals, however, and we'll look at this when we do covalent bonding a bit more, they can gain electrons to fill their outer shell. So typically we're talking about 8 electrons in the outer shell, so the non-metals will have 5, 6 or 7 electrons in their outer shell. So it's much easier for them to gain 1, 2 or 3 electrons than to lose all those electrons. And therefore they become negatively charged ions called anions. And remember they're on your information sheet as well. Why do atoms gain or lose electrons? Well, the group 18 elements, I call them group 8 because I'm old school, or the noble gases, are the most stable of the atoms. These elements are often referred to as inert or noble gases because they don't react, they don't bond. Basically they've got nearly the perfect atomic structure in terms of the nucleus and the electrons orbiting around them. All the charges are balanced, everything's fine. So most electrons and most of chemistry is governed by the electrons wanting to be find themselves in a better situation in terms of their electron shells. And the stability of these noble gases, or the noble inert gases, is due to their full outer shells. Atoms of other elements become more stable when they get a full outer shell. Doesn't mean they change into noble gases, it's just that they become more stable. They can do the charge balancing, and they undergo more chemical reactions by gaining or losing electrons. The whole point of much of chemistry is for atoms to gain or lose electrons to try and get this outer shell configuration. Atoms can become stable in one of three ways. By giving an electron to another atom, because the electrons just don't disappear, they're out there. By taking electrons from another atom, or by sharing electrons with another atom. So you can give, take, or share. So giving electrons, taking electrons, sharing electrons. When the atom gets a complete outer shell configuration, it does not become a noble gas. It stays the same element. Just has slightly different chemical properties and undergoes different chemical reactions because of its electron configuration, but it still stays the same element because the number of protons hasn't changed. Now, covalent bonding is the sharing of electrons. So when we do covalent bonding, we'll learn all about the sharing. The giving and the taking, that's ionic bonding. From atoms to ions. Atoms gain or lose to make ions. When an atom becomes an ion, it is no longer neutrally charged. It has a charge. By gaining or losing electrons, it has a charge imbalance. It's happier because it's got a full outer shell, but it also has a charge imbalance, and that charge imbalance affects its chemistry. Note that the number of protons remains the same. An atom that has lost electrons becomes cation, is positively charged, and we show this positive charge by a plus sign just there. In this case, the sodium has lost its single electron in the outer shell. It has an excess of protons, so it has a +1 charge. We don't need to write the 1 there because the plus sign indicates that there's a +1 charge. We can write the plus sign, the 1 there, if you want to. An atom that gains electrons becomes negatively charged and is an anion, and we show that by an example, chlorine. Minus, could have a -1 there if we like. Now, we're not limited to just +1 and -1. Atoms can gain or lose 2 or 3 electrons. So we could have +2, -2 ions. So here's a couple of examples. Here's sodium. The symbol for the sodium atom is just Na. The symbol for the sodium ion is Na+. Has the same number of protons, but what we've changed is the number of electrons. These electrons in the ion are in the configuration 2,8. So it's got a full outer shell. So it's lost this single electron in the outer shell. Chlorine atom, Cl, chlorine ion or anion is Cl-, same number of protons, gained 1 electron, so now it's got the electron configuration of 2,8,8. Electrons in the outer shell are sometimes referred to as the valence electrons. So we might just call them the outer shell electrons, but sometimes we refer to them as the valence electron. Or what is the valence of atom? For example, what is the valence of sodium? The valence of sodium is +1. Number of outer shell electrons is related to the group number in the periodic table. So on your information sheet, you can see how many electrons are in the outer shell from the group number. And in the next video, we're going to look at the formation of positive ions. So that ends this video, and hopefully you'll follow up with the next video.